All right, gang. These videos, there's going to be 3 consecutive videos here, more on annuities. I'll tell you what, let me grab my calculator before I get started. My assumption here is this is ending up the financial mathematics part after these 3 videos, and the assignment that goes with these 3 videos. We'll get into Markov chains, and then pretty soon we'll be preparing to study for the final exam. So the class is winding down. So, anyway, we got some more stuff before we get completely wound down. And so what I want to do, let me tell you the game plan. What I've got more on annuities part 1, more on annuities part 2, and more on annuities part 3 that'll be put up in 3 consecutive videos. What I'm doing here is just kind of throwing all types of problems in, and we're just going to work them, and you're going to have an assignment that has problems like these that are embedded in these 3 videos. So let's stop talking and let's get to work, okay? Now, Mrs. Smith deposited $75 at the end of each month for 7 years into a savings account that earned 4.2% interest compounded monthly. And one thing you've got to have is you've got to have whatever your payments are made. In this case, these are made monthly. Your interest must be compounded the same thing. So if this was $75 per quarter, then you would be compounded per quarter. Another important distinction when I read this is at the end. When you see at the end, it means you have an ordinary annuity. And that's the way things are set up. And I talked about this in a previous video. You know, when you go buy a car at the bank, they'll say, oh, you know, your payment isn't due for 30 days or whatever it may be, 28 or 30, depending on the way the terms of the loan. But you think that the banker's really giving you, you know, such a nice person for doing that for you. But if you think about it, by waiting, you know, 30 days, that interest is accruing for 30 days on the largest amount that the loan will ever be. So, but it's a common, you know, the bank is not trying to, you know, take advantage of you. They're just, it's just a way that of common practice. So anyway, trying to do this savings account. 4.2% earned compounded monthly. But there's a caveat here. She deposited an additional $5,000 at the end of the 5th year. So how much money will be in the account after 7 years? So if you think about it, she's done $75 at the first month and $75 in the second month. I promise you I'm not going to do this forever. And she finally gets down to the end of the 50th year, so $75 in the the 60th month. But then she decides to come in and add a lump sum of $5,000. So then on the 76th month, I'm sorry, $75 more in the 61st month. So the month after this goes back to regular schedule, but again, the caveat to this problem is this person came up with an additional $5,000 that they want to put in on this savings account. So, you know, how are we going to work this? You know, what I think I would do here is I would look at it part 1 and part 2. So part 1 is going to be up to the $5,000, and part 3 is, part 2 is going to be after the $5,000. So first part's going to be easy, right? You're going to pick up your calculator, and I'm going to go to TVM Solver. And up to $5,000 investment, that was at the end of the 5th year, right? So what I want to do there is I want to go 12 times 5. So I've made 60 payments. Guys, I'm going to go on down here and set the monthly 12 so I don't forget that. It's just what I do because I want to get the right answer. I don't want to get sloppy in something. Maybe the next problem will be quarters, and I leave this down here in terms of months, well, guys, you're going to get the wrong answer, and that's not cool. We don't want that. So I always set this, go down and set the periods per year. Again, monthly 12, quarterly 4, daily 360. We've talked about that before. All right, present value. Turns out there's no present value here. They start out with 0, but they put $75 a month into the account. So what we can do is we can go solve. And so $5,232. 0.75 is what they have up to the $5,000 investment. Now what happens? Now they're going to add $5,000 to that to get $10,232.75 as the beginning balance for part 2. So this happened right up here for 5 years. We want to see what happens after the entire 7. So that tells me I've got 2 more years to add on to this at $75 a month. Well, I'm just going to redo my calculator. So now, instead of 5 years, I'm going to have 2 years. Still have the same interest rate. But guys, now I'm starting out with the present value of $10,232.75. I'm still adding $75 a month to that, and I can get my ending balance. So gang, the correct answer here would be $13,441. 0.34. Sometimes students are confused about where to round. When you're dealing with money, I mean, it's pretty obvious. Unless, my math lab says round to the nearest dollar, in which case it would be 13,441. So, all right, gang, that was an easy one. We like that. Number 2, you have a choice of 2 increasing annuities, annuity A or annuity B. Which one will reach a future value of $50,000 the quickest? To me, this is just information that you really don't even care about, because what we can do is we can evaluate, say, after some term, and I'm just going to choose kind of a random term of 3 years. I really don't care about the 50,000. I'm just worried about which one is going to reach that the quickest. Well, if I can take a term of over 3 years and see which is the largest value, then I know it's going to get to $50,000 the quickest, because it's going to keep a consistent rate because the interest rate doesn't fluctuate. So I can just set some term, 1 year, 2 year, 3 year, 4 year, 5 year, whatever, and the one with the highest value at that time is going to reach the $50,000 the quickest. So that $50,000, that information right there is pretty much irrelevant in deciding which is the best. Okay? So guys, for annuity A at 3 years, what are we going to do? Well, we see out here that the periods per year are 1, so over 3 years, it's just going to be 3 times 1. I know that's redundant, but I'm teaching. Okay, real quickly, before I forget it, I want to make sure that my periods are 1. If you don't want to do that, don't do it. I do it because I want to get it right, okay? Interest rate is 9.2. The present value is 0. And we're making a payment of $1,500 per year. So we want to solve for future value, so go green key, enter. So 4926.70 is how much money annuity A will grow to after 3 years. All right, now let's see what annuity B will do in 3 years. Again, we don't care about the 50,000. If this value for B that I'm getting ready to calculate is bigger than 4926, and it's going to get there quicker. So don't care about all that. Now, if you wanted to, you could go ahead and put in future value. You could put 50,000 and solve for your N, But that sometimes gets a little tricky because you've got to take your N divided by your PYCY. So this way is much more straightforward. All right, guys, annuity B. So we've got what, monthly. So I'm again looking at this over 3 years. And before I get and do something goofy, I'm going to go down here and change that to 12. Interest rate is 4.8. Present value is 0. Payment is $250 per month. And I can see I get 9659.53. So, boys and girls, I used to never say boys and girls until I started doing P90X, and Tony Horton, I think is his name. He always says boys and girls, and I picked it up, and I can't get rid of it. So, sorry, I'm gonna blame that one on Tony Horton in P90X. All right, gang. So back to the problem. I do like my tangents, don't I? Back to my problem. If I have 9659, if this one's growing that much in 3 years in this one, so a little bit of common sense says that annuity B will get to $50,000 the quickest. All right, the Jones purchased a $425,000 home 12 years ago by paying 12% down and signing a 25% mortgage at 6.2. Compounded monthly interest rates have dropped significantly. So the Jones want to refinance the unpaid balance by signing a new 20. This is a complicated problem because it's got a lot going on. But nevertheless, we're going to have 2 time periods. The initial loan, and then the refinancing part. So let's look at what would happen. What we're going to do, we're going to compare these 2 values. So we're going to come in the initial loan, and we're going to find out, well, what would we have paid if we had done this? And then we're going to say, well, what would we have paid if we'd done the refinancing? So let's look at this initial loan first, okay? So let's get some information in our calculator. So we have initially, now, students a lot of times, they want to focus on this 12. This 12 is going to be important when we get over to the refinancing part, because that's what it says. 12 years ago, they did this, and now they want to consider refinancing. But the initial loan is calculated on the initial agreement, which was signed a 25-year mortgage. So they're doing monthly payments, so 25 times 12. Again, I don't want to mess up. Already set, so I don't have to worry about that. Interest rate is 6.2. The present value was $425,000. But there was a 12% paid down. Okay, so the total amount financed was $374,000. Now I don't know about you, but I would want to get out and make sure that there was no typos there, because if I start out wrong, I got no prayer getting the problem done correctly. So 425,000 minus the 12% down payment. It's kind of a strange down payment, but it happens. So 374,000 is what I need in TVM Solver. All right, so 374,000 payment we don't know yet. We want to be a good customer and pay off our loan. So go back up and get the payment. The payment is going to be so what is it? $24.55. 62. Okay, so how much would we pay if we stuck with the initial amount? Well, we would pay that amount times 12 times 25, right? Yeah. So we would pay back the bank a whopping $736,686. I had a student not long ago took my class, and he's like, Dr. Darbro, I don't think I'll ever buy a house because, paid $425,000 for a house, paid 12% down, financed $374,000. They almost doubled my money. Nevertheless, guys, there's probably no purchase that you can make that's more financially sound than a house. So even though these numbers are staggering and slightly intimidating, don't don't get confused. It's still probably in most situations the soundest way. It's a lot better than clothing or a boat or a car. All right, back to the problem, refinancing. So what happens over here? So what they did is they decided after 12 years to refinance. So what we need to do is we need to go in here and find our balance after 12 years. Now, got two 12s going on here, which really isn't good for teaching, but let me explain what that is. The first 12 is the number of years. So if this had been, they decided to refinance 15 years later, this would be a 15. The 12 is for the number of months because making monthly payments. Okay, so the balance at the time that they want to refinance, so the refi amount is $262,000, 559.89. So that's the amount that we want to refinance. And they want to refinance this amount on the unpaid balance, which is this, for a new 20-year mortgage. So let's go do that. It's the beauty of the calculator. We can get those things done very quickly. So the new mortgage is going to be for 20 years. Again, scroll down. Everything's good. The new interest rate is 3.75. The present value here is $262,559.89. And we need to calculate the new payment. So the new payment is $1,556. Kind of cool. They lowered their payment about $1,000 a month, $900 a month. So 1,556.69. All right, gang, let's compare what happens here. We've got two amounts paid. First of all, for the first 12 years, over here, they paid 12 times 12 times 2455.62. They paid this amount right here for the first 12 years. Now, we multiplied over here by 25 times 12 because we wanted to see what would have happened if they had stuck with this loan. Now we're actually looking at reality. This is just our baseline. What would have happened if we stuck with this loan, stay with this loan? What happens if we refinance? Well, they paid this amount, $353. Okay? So that's what they paid for the first 12 years. Now they're going to pay this amount for the rest of the 20 years that they refinanced. So they're paying $373,605.60. So I need to add these two things together. So they have paid $727,214.88. That's how much they paid over here. Now compare that to they only saved $9,471.12. Now, that doesn't sound like much, and around $10,000. And I don't know about you, but I hope I get to a point one day where I think $10,000 isn't much money. But still, it doesn't seem like a lot when you're talking about nearly $1 million paid. And the reason is over here they would have paid this loan off in 25 years. Over here they have the 12 years plus the refinance for 20. So they're paying on this house for 32 years over here as compared to 25. So they paid on it 7 years longer. What they would have been smart in doing, in my opinion, is when they signed this new 20-year loan, I would have only signed this over an 8-year loan. Now, sure, your payment's going to be higher, but you're going to get interest rates. Okay, your payment's going to be higher than 1556, but it's not going to be as high as 2455, and you would save a tremendous amount more money by. Actually, I take that back. The original was 25 years. So they were paying 25 years here over here. I would have refinanced this loan right here for 13 years. So I paid on it for 12, pay an additional 13, gives me the same amount here. But for this, I've got a cheaper interest rate, so I'm going to get a lower payment than that. So I would have saved a lot more money that way. But, people do what they got to do. Who knows? But nevertheless, even going out the additional 20 years, which adds to this, you still save money because of the interest rate being lower. All right, number 4, in order to receive $4,000 at the end of each quarter from 2020 to 2026, Brittany deposited $75,000 into an investment paying 2.95% compounded quarterly. Determine the amount of the interest earned by this decreasing annuity. All right, well, this doesn't even require TVM solver. Really? How much did she pay out? Well, she paid out $75,000. How much is she going to receive? $4,000 each month. So 20, 21, 22, 23, 24, 25. So 20, 21, 22, 23, 24, 25, 6 years. So she's going to receive back $288,000. Wow. On a $75,000 investment. Wow, she got some really, really, really good interest. I notice it says the amount of interest, not the rate of interest. So guys, all you got to do is just take this number and subtract that, and you get the amount of interest that was earned. So what is that, $213,000 over, wow. Okay, I'm kind of staggered by that because, okay, well, that's all you got to do. Anytime you got something that straightforward, if you know what you paid, you know what you're receiving, then the interest has to be the difference. All right, those numbers were a little wacky to me. The Parkers would like to have $25,000 for a down payment on a new house in 3 years. Now, guys, this is real life here because since the housing crisis a few years ago and subprime interest platforms and banks are requiring down payments in most cases. There are cases where that can be waived, but in most cases, a house purchase requires a down payment. Now, how do new couples who starting out and maybe struggling a little bit and trying to build some wealth, how do they make this down payment? Well, sometimes you borrowed from your parents, rich aunt, rich uncle. Yeah, it depends. But a lot of people have to prepare. So they know they want to buy a house in 3 years, and they know that the house range that they're looking at, the 20% of that's going to be around 25,000 for this example. They want to go ahead and start saving for the 25,000 so they can have this as a down payment. So how much should they invest monthly in a sinking fund? And that's what that means. You're putting in incremental payments to create end value. So compounded monthly. Well, guys, this is a very, very, very straightforward TVM solver problem. It's worth the price of admission to this class just to learn how to use TVM solver. Okay, maybe not. So what are we doing in 3 years? So monthly payments over 3. Guys, I'm going to go down and make sure it's 12, which it is. Interest rate is 4.7. We have a present value of 0. We'll come back and get that. But we want our final value to be $25,000. So what payment is going to achieve that? 647, let's just call it $648. Well, let's not call it that. Per month. All right, so that's a very easy problem with TVM solver. It would be a very difficult problem with the formula. I don't know if I've ever shown you all this or not, but the payment formula is pretty crazy. You put the amount of principal, so whatever amount you're borrowing. Then you have over in the denominator you have a compound fraction here, but you have the rate divided by the number of compounds. So this for monthly would be 12, quarterly 4. And then you have 1 minus 1 plus r over n to the negative nt power. So again, 1 minus this quantity, and then you get into a negative exponent. It gets really weird. A lot of students say, well, Dr. Darbo, I don't like TVM solver. Dude, let me tell you something. You may not like TVM solver, but you would like this much less. For example, what if you needed to go in and solve for a time it took for to a particular payment to pay off a loan at a certain amount? Then you get into some nasty stuff. There's some nasty algebra where TVM solver does the calculations behind the scene for you. Well, guys, I am done. End of this video. You're going to have 2 more videos coming up. There are 3 more problems I'll do in video number 2, and there are 3 more problems I'll do in video number 3. Have a good one.